we constantly tell people like you got to learn how to design for the process, and if nothing else, that's what's going on.
I would absolutely agree. And I think that's one of the things like I've learned in my civilian job working with additive manufacturing in UK defence is additive manufacturing is a really powerful tool if you use it for the right application.
Hey there, and welcome to Manufacturing Mavericks from TBGA. I'm glad you're joining us. Each episode, we shine a light on the people pushing the boundaries of advanced manufacturing. We explore the edge of technology, dive into economics, issues, trends, and critical ideas driving forward, with a special emphasis on the exciting world of additive manufacturing. From new technology breakthroughs and industry trends, especially in additive, to the everyday challenges people face on the job. But we know there's more to work than just work, so we dig into leadership stories, life lessons, and the quirks that make this field fun. And yes, you can count on some dad jokes and puns along the way because what's a show without a little groaning? Thanks for tuning in. Let's get into it and meet the people who are making manufacturing what it is today. I'm John Barnes, founder of the Barnes Global Advisors and Metal Powder Works. I'm a materials engineer with two daughters and two golden retrievers. Joining me today is Alex Champion, who's serving with the United Kingdom's Ministry of Defense. So, Alex, it was just Thanksgiving here recently. My family wanted me to promise to refrain from puns at Thanksgiving, but I just couldn't. I couldn't quit cold turkey.
Very good.
Yeah, I,
Very
I
good.
figure while you don't share the Thanksgiving, I figure the puns have to hit. So, welcome to our podcast. It's episode 3.
Thank you very much for having me. It's good to be here. Yeah, it's good to have a chat. Glad we can make it work in the different time zones.
Yes, and we just recently saw each other in Germany at FormNext, and we had very optimistic thoughts that we were going to do this
Attempts.
in person,
Yeah.
but that was clearly diluted and optimistic. So, where are you joining us from today?
So I am in Newbury in Berkshire, which is my home. So in England, about an hour west of London, hour and 15 minutes outside of London, fairly central to kind of lots of key Ministry of Defence sites, so a good location to be in. Interestingly, it also feels like the unofficial home of additive manufacturing in England at the moment. There are lots of AM and other digital advanced manufacturing companies around here. So yeah, it's a good location. It's not as hot and sunny as I'd like it to be in England today, but it's not too bad.
We met in Tampa. It was around the Mill AM thing, and it was in all places a sports bar.
It
And I
was.
think I think we just I think I bumped into you or something, and I excused myself, and we're just started to have a bit of a chat right there on the spot. How long have you been doing this? You have a degree in motorsports, I think.
Yeah, so I graduated from my engineering sort of technology degree in 2011, 4-year degree because I didn't have enough maths to get onto the course. So I had to do a kind of a foundation year in maths and physics. And then, yeah, 4 years degree in which I spent, to be honest, as little time doing academic study as I could get away with. Spent most of my university time either volunteering for race teams, going cool places, doing engineering, doing manufacturing, playing with old racing cars, playing with old racing motorbikes, having an amazing time of it. But the academic piece was very much the thing that enabled me that time. And then the other half of my time I spent when I wasn't studying was not doing motorsport, but doing what we would call in the United Kingdom like the Officer Training Corps, which is like a kind of
Mm.
an initial National Guard unit that does a lot of military instruction and military training. So from very early on, I had a real passion for kind of making stuff, and I had a real passion for, or a basic understanding, I would say, maybe for defense.
Were you a bit of a tinkerer growing up too? You take stuff apart and
I was a late developer, I would say. I got into motorsport as a result of reading a book by a engineer called George Brown. In fact, it's about George Brown. It's a biography written by his brother Cliff Brown, and he was a very competent engineer and racing motorcycle character from Cambridge in England, sort of Cambridgeshire, Stevenage, and really through the 1940s, 50s, 60s, and 70s, he was one of the fastest men on the planet. He had a Vincent motorbike, which he heavily tuned. And I read this autobiography, and he talked about racing in a town where I was born and grew up in Brighton, down on the south coast. and he used to race along the seafront at an average speed of sort of 150, 200 miles an hour. And I know that stretch of road really well, driven it many times at sort of 20 miles an hour, 30 miles an hour. And so reading that autobiography really gave me an interest in going and studying engineering. I knew if I did end up joining the military, and I thought I might want to as a sort of 16, 17-year-old, having an engineering degree was a really valuable thing to have. Kind of that's how I fell into engineering. My father had some old motorbikes. And so to try and apply some of the theory I'd learned, at university, that's how I ended up playing with old motorbikes. That's how I ended up playing with old racing cars. And the two interests kind of developed in tandem.
Was your father or mother in the military?
My father was a plumber by trade and taught plumbing for his whole life in the same school, but he had a real passion for old motorbikes,
Mm.
especially old British motorbikes, and he had quite a collection of interesting, unusual, rare, and unfortunately usually not working old motorbikes. So if I wanted to get into riding motorbikes, I certainly had to get into fixing them first.
That makes perfect sense. Yeah, it's interesting. We have a Reserve Officer Training Corps, ROTC here, so that you typically get involved with at the university level. So I
Yeah,
initially started off that way with Navy ROTC. My dad was in the Marines, so being supervised by the Navy, went into the ROTC, but found that I didn't really like getting yelled at too much. So
that's
I
fair.
decided to, but the inspiration actually speaking of books, like I read the book Jaeger as a teenager, and that was just like mind blowing, fascinating to me that really a guy with not much, almost had more physical training and intuition than academic training,
Yeah,
and just had incredible eyesight, which is what earned him his ace in World War II, and then went on to become a test pilot, which was got to fly everything. So anyway, that was it's interesting where people either incidentally or purposefully find
yeah.
motivation. I remember telling one of my kids that they were like, well, science. I like science and math, but I don't like calculus. And I was like, I've been doing engineering for 30 years. I've never once done a derivative. Like, I appreciate it. I'm glad that other people really are good at it, but hasn't really wandered into my daily activity.
I absolutely agree. And I look at my engineering degree and the academic study of technology that I have done until now, and it absolutely provides a good solid foundation. But I do not use Bernoulli's equation at all since I have finished, my aerodynamics module at university.
Is there a thread here between this, service minded being a reservist and then this advanced manufacturing piece? Because it's, I mean, I think having the fundamental understanding of how motorized or mechanical things work is generally helpful. Something I didn't have. My degree's in materials engineering, so we don't naturally study the Carnot cycle, and our thermodynamics is a bit different in terms of metallurgical thermodynamics. Is there a pattern with the reservist activity, or because you're very active in additive or
I am.
advanced manufacturing?
I am. And it's a good question. Yeah. How do we correlate the relationship between reserves and engineering? I don't know, but I think that there is a relationship. I look at some of my other reserve colleagues, and I've got colleagues I've got two that work at Williams Formula One team. One is in the infantry, one is a driver in the logistics corps, driving trucks and cars and stuff. I know one of my soldiers, again, works in logistics. His job is like senior design engineer for gearboxes for another Formula One team, I think Mercedes. I've met other reservists at Red Bull who are systems engineers at Red Bull, and I think there is a link between people who like doing engineering and people who like being reservists. I would absolutely agree there is a link. I don't know why. I
Hmm.
wonder, and I speculate maybe there are some psychologists that listen to this that can maybe give more of an answer. But are we just the sorts of people that like doing things? We like being involved. We like getting our hands dirty. We like, biting off more than we can chew. Are we all of a similar mindset for that reason? We like contributing to a bigger purpose.
I think that's inherent in engineering. There's no romantic vision of an engineer working alone at a bench and discovering the next element, or there's that difference between scientists and engineers. I think that engineers always, at least true for me. It sounds like it's true for you, which is like it's a bit of complexity. You're trying to apply the knowledge that you have into any given situation. which is at some level a service component. Maybe, like you
Agreed.
said, maybe there's a psychiatrist or a psychologist out there that can give us a free diagnosis.
Take that apart and have a look at it, see what's inside, see what makes us tick.
We met through additive manufacturing, but you do more than that. So where does additive fit into your daily, weekly existence in amongst the other things that you do?
Sure, yeah. So I guess a really quick overview of how I got to where I am today. After finishing university, I worked for a small company that designed and manufactured kind of bespoke and low volume transmission components for mainly historic motorsport and single like racing series. So I was designing a lot of clutches, sort of 7.25 inch multi-plate racing clutches, a lot of flywheels and transmission release bearings. So everything that basically goes inside of what the UK would call the bell housing, which is the bit that connects the engine to the gearbox. And I really loved that. It was a really cool job. I was passionate about historic motorsport, so it was easy to kind of fit in there really comfortably. The problem is it's a very niche thing. And so as a sort of 21-year-old, you suddenly find yourself being like the absolute expert, like the biggest goldfish in the smallest goldfish bowl. And it really quickly became clear that like there's so much more to engineering than like I can't stay here doing this forever. So I moved to a new startup company at the time called Lentus Composites, based just outside of Oxford, who had started doing carbon fiber, mainly filament winding for things like prop shafts and drive shafts. So, carbon fiber tube effectively. And that was fascinating. Like their level of engineering understanding was so much higher. They always say it's good to be like the dumbest person in the room occasionally. And Lentus certainly was that for me. It was a very steep learning curve. I think I was probably quite lucky in the first company I worked at. It was a very small company. Whereas when I went to Lentus, like very, very technical, very competent, some very motivated people. We were working exceptionally long hours to get this company from nothing to something in as short a period of time as we could. And very quickly, we started finding ourselves getting, top tier Formula One teams as customers, like serious aerospace customers wanting carbon fiber and composite bits. We started doing more and more like pre-preg laminate, like exotic, very high quality composites. And as part of that, Lentus got the contract to make some racing bikes for the Rio Olympics for Team GB. As part of that, the bicycles came in kind of three main key sizes for the frames because most cyclists are around the same like body demographic. But we then used titanium additive manufacturing to make things like seat posts, pedals, cranks, handlebar spacers, and things like that for the different kind of omnium bikes, the sprint bikes, all the different type of riders and the different types of racing. That was kind of my first introduction to real additive. Yes, I'd done a little bit of sort of FDM prototyping, but tiny, like one or two parts. And really, my first introduction to end use parts was TI64 laser powder bed fusion, printed by a company just south of Oxford on EOS 1790s. And as it happened, within a year, I was working at that company. That's kind of how I then moved from Lentus, doing, trying to rapidly scale from a small startup to a kind of a fairly mature aerospace and motorsport accredited company, to working at what was 3T Additive Manufacturing, where we were working with, again, lots of motorsport teams printing TI64, Inconel 718, 625, pure copper zirconium, sort of ALS energies, like all the usual ones, sort of 17 EOS machines. And that for me was kind of a real eye-opening, like this is a really interesting new technology, very different to the CNC machining I've been doing at Helix, very different to the filament winding I've been doing at Lentus, but actually a lot of the same problems. How do we test our materials? How do we inspect and like dimensionally measure our parts? How do we have good quality engineering, repeatable processes that ensure, right first time, on time delivery in full? We are hitting our production schedules for 10,000 parts a month, 20,000 parts a month, your tack times. And so all of these three different experiences taught me useful skills and lessons for making stuff, which was fundamentally what I was passionate about.
And so, well, and of course, 3T just recently got acquired by SBO, I think. So
Yes.
that's a sign of maturity in the industry. And I'm just curious, you mentioned all of the key things that, sort of are essential in manufacturing. Did you see, based on the composites experience, any similarities to additive? And then secondly, was it more of a, hey, this is a solution to a problem that we have over here, like additive in that case, being able to do more bespoke fittings? versus like, oh, this is cool. I'd like to play with this for a while.
I do absolutely see alignment between different digital manufacturing and advanced manufacturing technologies. When you look at composites or additive, like you're starting with effectively ingredients and you finish with an end use part. Literally, some of the machines we had for testing quality inspection in composites were the same as in additive. Microscopy, so cutting stuff open, looking inside it, looking for things like voids, contaminants, defects, absolutely identical in metal AM versus filament winding or laminate composites. The use of tensile test machines and fatigue testing, like so much fatigue was going on in composites at the time. We used to have like a 50 kilonewton and 25 kilonewton machines running sort of 4 hours a day, generating SN curves for fatigue data. And then when you come to additive manufacturing and you're looking at like TI64, everyone always starts by saying, yeah, but what about fatigue? Like fatigue is where you start seeing good or bad quality metal AM. Fatigue. So definitely some overlap. I also look at some of the things like DSC for testing polymer, like glass transition temperatures. Very relevant to composites for seeing like has your composite cured correctly in the autoclave or in the oven. But DSC can also be used for things like polymer SLS to look at how is your laser interacting with your laser powder in like an SLS machine. And so again, like there were definitely overlaps of like material inspection on that Venn diagram, as well as geometric inspection, things like CMMs, blue light scanners, things like that. But I would also say just overall, like manufacturing processes were identical. If you're working to an AS 9100 revision D aerospace classification, you're going to be using things like potentially a failure mode effect analysis, like PFMEAs. You're going to be using control plans. You're going to be using like visual standards documents, stuff like that. So yeah, across all manufacturing technologies, there are key themes.
It's interesting. I've used the analogy many times in the metal side with additive, with this notion that what's different about it is you're creating the material while you're making the part. And I really hadn't considered that composites is a little bit the same way. Certainly, if you're using like fiber placement or tape laying, you are starting with pellets and fibers, and you're winding up with a component at the end of it. And I always used to joke when I was at one of the aerospace companies. I saw one of our advanced products, and we were non-destructively testing it by bouncing a quarter off of it just to see if we could hear, any delaminations or defects in the skin. So it's good to see that we have some more advanced methods these days.
We do.
But it sounds like it was, kind of coming back to this piece of it was cool versus it was solving a problem. It sounds like I was actually solving a problem.
Yeah, and applications wise, I kind of already talked about it, but these were fairly like punchy, high end applications. This was drive shafts for aerospace. This was fairly safety critical Formula One parts, and so understanding your processes, understanding your procedures, understanding your machines and your materials, like making sure your people are like have good processes to follow and are well trained in them, like always was again like the key theme, kind of agnostic of whether you're using a laser cutter or a plasma cutter or a filament winder or a laser powder fusion machine.
And so did you have, were you supervising people there? Did you have teams that you worked with, or how did that work?
Not so much. At this stage, I was kind of working either as a manufacturing engineer, a development engineer, or working kind of in a sort of BD and sales team, but as the engineer to support across both the composites and then the metal and the polymer additive stuff. And then I ended up kind of running a team at the next business I worked at, which was an FDM 3D printing polymer company called E03, that are an incredible bunch of young people making like next generation components for FDM machines. And that was really the first time I saw kind of and learned in detail about what most people think of as 3D printing. And so, yeah, it was quite late on in my career when I was running sort of an applications team. It's just a very, very small team working directly with 3D printer manufacturers to help develop next generation parts for FDM 3D printers. And a huge part of that was me getting my hands on prints, printed parts, hot ends, extruders, heat breaks. And so that was, again, like a significant learning process. Although it was like we're now looking at making the machines rather than making the parts.
I'm just curious, kind of going back to this other thing, it just popped into my head. So you're supervising, like you said, a group of bright young people here. As an officer, you're leading people. Do you find similarities between? I imagine the backgrounds are quite different, but it's a little bit of a service when you're trying to develop a technology and applications. There's a service-minded attitude there. If you're not interested in that stuff, you would probably go seek a degree in finance or something.
Yeah, that's a really good question. It's one I've not really considered before, but yes, I think there probably is when you look at a very small team. I mean, at the time we were mainly working on some hot ends, so on the FDM printer, like the nozzle, the heat break, the heat sink, kind of for two major 3D printer manufacturers. And like I was running a team at the time, quite a young team, quite a newly formed team, but fairly sort of single-minded on these kind of couple of products for a couple of customers. Whereas when I look in sort of my Army Reserve role, like it's a lot more practical, like driving trucks somewhere. Like the majority of what we do is kind of training. We are not driving trucks overseas in support of deliberate operations at the moment in the British Army Reserve. It's certainly in my unit. So I think there are some similarities. For me, the thing that was probably the most valuable is the experience, being able to be in the Army Reserve, leading people, occasionally doing training exercises. If it all goes wrong, or if I do something I wish I hadn't done, like it doesn't really matter because that's training. Whereas then I can take all of that learnt experience and I can turn up as a leader for the first time in my sort of full-time job and just have a little bit of experience of like managing people and working with people and helping them to develop. And I think a lot of those silly, smaller mistakes that I've probably made in the reserves, on an insignificant, inconsequential training weekend, are now kind of worked through, and I've learned from them, ready for having an actual job as a manager of people. So I'd say from that way, it's very beneficial.
I know at Lockheed, our perspective was like making mistakes wasn't a bad thing as long as you learn from it. And of course, of course, you want to do that in the right kind of environment. But recently, somebody showed me a quote from Eisenhower, and I'm going to get it wrong, but paraphrasing, it was like, "Plans are useless, but planning is essential."
Yes, that's actually
So
one
just
that I saw recently. It's a very, very, very useful quote.
so it's again, it's the same thought, which is like the exercise of thinking effectively is what chance favors the prepared, or my other favorite quote is, "Experience is what you get when you're looking for something else."
Yeah,
Which, now that we're renovating our house, it was built in 1906. We learn that seemingly on a weekly basis. So we so we have a little bit of this leadership piece, the service piece. Now you're involved with, which is how we met in the MOD activities. Before I jump into that, so the one thing I always try to make is like, I think, and let me know if you agree with this. So I wrote an article with some other people, one from the U.S. Army, one from the Navy, which is, manufacturing of defense products isn't like, you're not just making the Eddie Bauer version of the Jeep. It's a fundamentally different design.
yeah,
It isn't just about making it, it has different requirements. It's going to get dropped out of a plane. It's going to get, launched to shore, whatever the situation is. Of course, I'm a big fan of the C-130. C-130 has been around since 1950s, and we're still finding ways to make that airframe do new things. But because it's almost a testament to the engineering of the airframe that allows it to do all of these things. We're going to fly B-52s for 100 years. And that's not a throwaway design. There was, we understand that effort. So I'm wondering, in that context, the appreciation of, like you said, okay, you're driving trucks, but you do have to appreciate how the truck works and where it excels and what it doesn't do well. That doesn't really matter where you're at geographically. Leading into being able to use additive to manufacture or repair or augment some of these defense products. So there's a bit of a question there. It's not so much a statement. And then I know you've been busy with Ukraine, so I wonder if there's can you wrap that in a nice package for us? Like what are we learning overall in Ukraine versus how it relates to the nature of defense products, maybe more specifically?
Yeah, happy. So I think for me, like I'll start by saying, like, unfortunately, or I guess fortunately, like I'm not heavily involved with Ukraine, but what I am doing is making sure I read every piece of open source literature I can find on Ukraine. And there have been some absolutely fantastic articles on Forbes and BBC, the British Broadcasting Association, and in like the New York Times and some of the UK, like the Telegraph newspapers, talking about Ukraine supply chains, talking about manufacturing in Ukraine, talking about their repair facilities. And sometimes it's not about manufacturing. Sometimes it could be about drones and the acceleration of like drone war. But when you look in the background, you can see the 3D printers running, and you can see the sorts of parts they're producing. So for me, like 2025, open source ability to gain information has never been easier. And so I can sit here and I can see what I've learnt from Ukraine. Like, we do see additive being used all over the place. We do see polymer FDM machines are absolutely spread across the battlefield to modify, to repair. I do see pictures of 3D printed drones complete. I don't know how the Ukrainians get on with those. I'd love to find them and ask them and meet them. I know people in the UK who have flown 3D printed drones and say actually they're not always that good. They need a lot of PID tuning. They have a lot of problems. They're slow to assemble. You still need a supply chain for things like batteries and motors and controllers and wiring and everything else. And so actually, maybe for the sort of quantities that those guys are using those drones, maybe it's a case of, find a higher volume manufacturing technology for making the big bits, and then just 3D print like a build plate full of camera mounts or motor mounts that hold the electric motors, or a battery clip that put a cable tie through and holds the battery on. Finding those small complex bits that enable you to assemble the drone or add complexity or modify the drone. But start with, I saw a really good article in one of the newspapers that said the Australians are now providing corrugated waterproof cardboard drones. Like cardboard, brilliant, great technology, cheap, fast to produce, stamp it out, couple of folds, some basic origami, and you've got like the wing and fuselage section of the drone. It only needs to last a few hours. It's waxed cardboard, so it's reasonably waterproof. Right now, we use the 3D printer to print the thing to the mount for the motor, the mount for the camera, the mount for the battery or the engine or whatever it is. Like, that is where I see additive being very useful. The small, the complex, the integrator part, rather than maybe making the AM part complete. But again, this is just what I've seen open source. I'd love to be challenged on that.
It seems like, well, beyond the obvious, I feel like I have this relationship with Amazon now where all I'm doing is disassembling boxes to be recycled. So maybe they need to get together with the Aussies and figure out how to work that together.
Better way of, a bit more circular economy on that. I absolutely agree.
Like the drone thing, okay, that works in this theater, and that's a thing, much like in the previous activities that the US has been involved with, like IEDs was a big thing in the past. So, every conflict, there's a new thing. It seems like, though, with the drones, that it kind of plays into a theme for 3D printing, which is this rapid design cycle. It's not gearing up to make a million of the same thing, because next week you're on to, it's a cat and mouse game. It's spy versus spy, which is like, well, we did this, so they did that. We're going to do this now, and they're going to do that. And so it is a constant modification game. And it does seem like that plays into one of the key strengths, regardless of whether you end up making the million parts. Like you said, I mean, it's just like with composites on wing skins. Perfect application. Barrel sections depends on the size of the airplane. It's never like there's just only one answer. And it feels like this, we constantly tell people, like, you got to learn how to design for the process. And if nothing else, that's what's going on.
I would absolutely agree. And I think that's one of the things, like, I've learned in my civilian job working with additive manufacturing in UK defence, is additive manufacturing is a really powerful tool if you use it for the right application. There's a common saying, like, when you've got a hammer, everything starts to look like a nail. And that's what we've got to be really careful of, because there are absolutely things you can 3D print that you'd say, why do that? That's slower, it's more expensive, it's not as good. But there are absolutely things that you can additively manufacture that are absolutely superior, and there's no other way you would want to make it. And so understanding, and I guess that comes back to like a training piece of, finding the right applications, going after the right parts for the right reasons. It's a bit of a journey. We all start with the wrong stuff, but that is so important. And then for the stuff that's not additively manufacturable, how are we going to make that? What are the other tools that we want in the toolbox that mean that we can, make parts, maybe temporarily repair parts? Maybe we don't always need to make stuff, but
That's it. Yeah. So, in our we have a supply chain or value chain or kill chain, whatever you want to call it for additive. And the first two questions are can I, should I?
Yeah.
And should I is a little bit the why am I doing it this way? So to your last point, sometimes I just need what I need and I need it now. I don't I can't wait 6 months to get it. We sit here I do my honorary commander thing with the 171st Refueling Wing, and they were telling me about, for want of a pretty inexpensive part, they were grounded in Guam for a month, and I'm like, I could make that. I could make that
Yeah.
in a day.
Yeah, I absolutely agree. The horseshoe nail, we would refer to it as and there's a poem that talks about, for the fact of a nail, for the want of a nail, like effectively the war is lost,
Hmm.
because you can't use the piece of kit on the day you need it when you need it. I look at additive, certainly through my civilian role, as being kind of two very different sides to the same coin. And I recently stood up at an engineering event and I kind of gave a talk about the fact that this is two sides to the same coin. Like, on one side of the coin, we have deployed soldiers, probably making temporary repairs, making non-safety critical, non-structural parts, stuff like rubber eyepieces for a pair of binoculars as a temporary spare part. We don't want to make a new pair of rubber eyepieces for binoculars. We just want a new pair of binoculars. But they're not coming through the supply chain for a number of days or weeks or months or whatever. And so we can keep using the old ones by printing like a pair of rubber eyepieces. No worrying about certification, no worrying about intellectual property rights. Like, why wouldn't you? Perfectly suited TPU, a little $200 3D printer, good to go. And I see that as being a fantastic use of additive or advanced manufacturing in wartime on operations. But then I also look on the other side of the coin, and I see some of the exquisite stuff that people like Boeing and Airbus and Lockheed Martin are producing. Titanium, safety critical components in use in flight. And I say to myself, like, that is a really impressive use of additive manufacturing, but they are two different sides to the same coin. Like, I would never expect like a junior soldier to start 3D printing safety critical parts for jet engines
Right.
in a in
A, a trigger
in,
cover is much different than a wing box.
exactly. And it's about knowing who needs to do what where. And the UK Ministry of Defence has now published an AM strategy that talks about how we tie those two users together, because whilst they are different users and they have different applications, there are definitely things that we can do that are complementary. So what can we do to get people on the exquisite side of the coin doing a lot of the design for manufacture and prototyping and certification work, so that they can then send forward digitally those design files to those individuals that are further forward, that don't have the space, the time, the competence, the capacity to start doing some of the more advanced stuff. And then suddenly we can start seeing like these two overlapping wedges of, side one of the coin being deployed users with simple printers, side two of the coin being exquisite users with complex printers. And that overlap can very quickly grow by using, digital file sharing technologies and having experts in the UK with deployed users forwards being heavily and closely supported. And yeah, when you read the UK strategy, it talks about dispersed, remote hubs of manufacture that provide supply chain resilience. What we're not looking to do is replace our defence primes. Like, we're not looking to, the British Army never wants to make its own tanks. What we're looking at in the forward space is temporary repairs to enable the tank to remain mobile until the original spare part comes through the supply chain. And that could take days, weeks, or months. And so, yeah, we're looking at reinforcing, we're talking about resilience. We're certainly not talking about replacement of supply chain. And when you think of it like that, those two sides to the coin working together, make a lot of sense.
With the defense piece, this ability to, what is the cost to acquire something new? And people, oh, well, that's just defense. And I was at the other a couple of years ago, we had a customer. We were trying to work with something, and we said, "Oh, well, we'll get you a dollar lease. You can just have access to it for $1." And they said, "Yeah, that's not going to work. It costs us $5,000 to cut a check."
Yeah.
So it's all just relative. It depends on how you
Yeah.
want to look at the math, and there's costs in doing low value tasks. But the flip side is the difference is a tank is not a low value item, and so having it doing its job is worth a lot.
Absolutely.
We work a lot with the Navy, and it's saying, well, we can't get this part for a certain ship, and then there will be an argument that says, oh, well, additive costs more than let's say the cast part. And so, well, the cast part that you can't get is the most expensive part. Doesn't matter how cheap it is if you can never have it. So
Right. Going on from that, I would say the Navy is a really good, obvious use of additive. When you're in the middle of the Pacific or the Atlantic Ocean and something breaks, you can't just order it on Amazon and expect it to arrive next day courier.
mhm.
And so the ability to have basic manufacturing on board a ship to do temporary repairs completely makes sense. Like, ships are big enough, expensive enough, that like they are strategic assets. They have to be able to go to sea and stay at sea. An aircraft carrier can't just say, "Oh yeah, well, the oven door's broken in the galley. We therefore can't go to
Just
sea."
turn
Like,
around.
yeah, wrong answer. An additive is a really good way of doing that. My question is, like, does the ship need to have the full design library before it goes to sea so it can print? Maybe yes. There's a lot of items on a ship that could break. Could it therefore be that we have a design engineer back in the UK who can be supporting the 3D printer guys on board the ship, or do we need to train those users on board the ship to do it themselves? And I don't know what the right answer is. I don't think there's a wrong answer as long as we're making progress.
Yeah, it's a little bit like this conversation with expeditionary manufacturing, and I think that has lots of different uses and definitions, and it's almost like asking any three materials engineers a question, you'll get six opinions. There's something there. I'm not sure we've sorted exactly what it is. It does depend on the use case, because some additive is a bit more process intensive. It's, with at least with metals, certainly with tie, the powders matter, the wire matters, heat treatment matters, machining is a thing, inspecting the part, da 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 da. Whereas if you're trying to make something work, printing a tool, okay, that's easier to think about. Repairing the binoculars, that's easy to think about. And so there's this, I'd like to throw this stat out. The U.S. Defense Logistic Agency manages 9 million part numbers.
Yeah.
It's a good chance that some of those could be 3D printed by a soldier, sailor, marine, airman, in the field.
Agreed. I think there's a real easy, like, crawl, walk, run analogy we could use now. It's a bit cliche, but I think it works. Set your sights really low, 3-4%. But 3-4% of a few million items is still a lot of items. And that's going to be the really easy stuff. That's going to be the stuff that just makes complete sense. And then once you've designed those and you're making them in volume, you can then increase your appetite, increase your ambition, maybe start looking at new technologies. What other tools do we want in the toolbox? What families of parts? We know rubber eyepieces for binoculars work really well. What other rubber eyepieces do we need? And then suddenly that 3, 4, 5, 6% suddenly starts growing towards 10%. And then once you've printed a few thousand of these components, your ambition and your understanding of the technology and your maturity grows, and your willingness to print more important parts grows. And then suddenly you'll find yourself, like, maybe not printing safety critical parts, but maybe safety related parts very quickly become within scope. And then suddenly that 6-10% becomes 10-12%. And that, I think, is really valuable. We don't need to immediately start by saying we're going to 3D print jet engines or 3D print nuclear reactors for ships. Like, let's start with the rubber eyepieces. Let's print them to a really high standard en masse for 5 years. And by the time you've finished doing that, you'll have a much better understanding of certification, assurance, machine maintenance, training, like all of these kind of key topics in the UK Ministry of Defence. We call them defence lines of development. The mnemonics: tepid oil, training, equipment maintenance, policy, information management. These are all material agnostic things. We don't have to be making titanium safety critical jet engines.
Right.
Like, we will learn a lot of these things from just printing like a rubber eye seal.
But it seems like a couple of things we talked about. If there's a theme there, the engineering of these defense articles, from jeeps to tanks to whatever, you have to understand how those things work and what they're intended to do, and what are the requirements, why are there requirements, and then you come kind of forward to, if you're an expeditionary unit, such as the Marines typically are, you know, you might wind up in Afghanistan. I doubt that too many US teenagers knew where Afghanistan was on a map, much less what the environment that they're going to be in. So the plan is terrible, but the planning is helpful. And
Agreed.
so 3D printing allows you to be a little bit, well, we always say adapt, overcome, persevere. It's an ability to do that, because you don't know. Even if you're on a ship, there's a good chance at some point you're going to get diverted because you're on a 6-month cruise, where the plan probably doesn't last, but maybe a couple weeks into the cruise, and then you're going to respond to some event someplace, and you don't know what you're going to be up against, so you kind of deal with what you have.
Agreed. And additive definitely provides or can provide that resilience if used correctly.
Well, we've covered a variety of topics. I think you're also coming up on a new adventure. You've got a child on the way in February, I
Indeed.
believe. That's
Correct. Yeah.
exciting.
Yes.
So no doubt there will be a 3D printer in your home in due course. Any last thoughts or questions that
I
anything?
guess I'd go back to just comparing, like in my project, Project Tampa, where we're working with vehicle manufacturers to try and get them to design and print parts for defence. And then I look at the work, soldiers, sailors, and aviators are doing in the Ministry of Defence to try and adopt 3D printing. And I compare that to kind of where my career started. And it was interesting, like at the start of this conversation, we talked about my early career and my like time at university and stuff, which is something I don't really think about that often and haven't thought about in a long time. And I see some of the things we were overcoming in motorsports, working, with Formula One teams, and I look at kind of where defence is going, and I do see overlap. I do see alignment. Both have in some ways similar problems they're trying to overcome. Both are working with usually quite complex pieces of equipment that are in fairly low volume. You look at a Formula One car, each team's got a couple of cars. You look at the Royal Navy, they've got a couple of aircraft carriers. I'm not saying an aircraft carrier and a Formula One car are in any way identical, but like they're low volume and they're complex. Both of them, on the day when you need them, at the start of the race, at the start of the war, both of them have to be operational. And it does not matter if you've got the best Formula One car on the grid. If the day before the race your car doesn't run, you're not going to win. And in Formula One, we always used to say, to finish first you must finish. And I think that the Ministry of Defence will absolutely understand that priority and that importance too. Both of these complex bits of kit, whether it's an aircraft carrier or a Formula One car, are very rarely used in our own country. But when you look at the Formula One timetable every year, there's only one race in England at Silverstone. The rest of it could be in Australia, Canada, America, all over the place. And how do we support that remotely? And it's really interesting to see so much of a Formula One car is made using additive. There are lots of metal safety critical parts printed on a car. There are lots of printed parts, I am sure, in military equipment. I don't know how many there are, but I would be confident to say that all of our aircraft will have AM parts in it. Most of our complex, larger pieces of equipment will have something in AN in them at least. What I don't see, though, in motorsport yet is them deploying 3D printers. I think it's probably because Formula One events last such short duration. It's a 40-minute race. It's a 1 hour, you're there for a weekend and then you're gone. And I think that the speed of the 3D printer, if the car breaks down, you don't have time to print a new part and fit it and repair it.
Most conflicts are longer than 40 minutes.
But hopefully our conflicts are going to be longer than 40 minutes. Whilst they are different environments, whilst they are different use cases, I think there is also a lot of overlap. The ability to rapidly mature technology, I think defence could learn a lot from. The way Formula One have a really good understanding of materials and manufacturing technologies and design for manufacture, and like which is the correct tool in the toolbox. You would never 3D print a front wing that's made from carbon fiber. You would never 3D print key components of the car. You'd never print the wheels. It's just the wrong application. But you would 3D print like the turbo housing, the exhaust system, the oil pump, because they are the right parts for the car. And I think that there are many examples where defense and motorsport could probably overlap, share some good learning both ways, because they are actually very similar in many ways.
Well, that's good stuff. I think we will wrap it up,
Cool.
and hopefully you'll have a nice holiday. And
Thank you.
then looking forward to February. We'll change your life in ways that you
Yeah.
also can't predict.
Yeah, daughter due mid-February. It's going to be exciting. It's going to, as you say, change the life.
Very good. Well, thank you, Alex, and we'll
Pleasure.
see you soon.
Cleared for takeoff.
You've been listening to Manufacturing Mavericks, hosted by John Barnes and powered by the Barnes Global Advisors.